But recognize your organic acids and recognize these as acids. Now let's look at bases. A base. A substance which has a metal plus hydroxide or OH group. Let me just put it that way. OH group in the formula and produces hydroxide ions in water solution. Okay, your substance. And this is your classical definition of a base, so the original. Your substance has a metal and a OH group in the formula, and when you put it into water, it produces hydroxides, or OH minus. Can you think of a base that you've worked with in the laboratory? I know in Lab 10 you worked with one. Does anybody remember it? Anybody remember it? Okay, I think the one you've worked with is this one. NaOH. Okay, what you need to be able to do is not come up with one, but if I write it, you can recognize what it is. You see the metal out front, you see this OH out back, and we're just assuming it's going to produce hydroxide once it gets into water. Now, would I have suckered you in if I went back to this organic substance? It's got the OH. What is it lacking?
The metal.
The metal. So that's not going to be an acid for us or a base for us. So we can recognize bases. Bases are fascinating because they dissolve skin and hair. And what's some uses you can make of it? Drano, that kind of product. Because if your drain, your shower drain is clogged up, chances are excellent it's with hair. If you wash your hair in the shower, you wash your dog in the shower, so you pour some sodium hydroxide or potassium hydroxide, just a hydroxide down the drain. You let it sit there for 10 minutes or so. It dissolves the hair. I don't think you'll have skin down your drain, or not that much of it. So you've got skin and hair. It dissolves, then you flush it with water, and it clears your drain. Now, if it's your kid's Lego down the drain, that's not going to work. But if it's skin and hair, which is more likely, then that's going to work great. So how do they use these things? Another use besides Drano, even more fascinating, they use this one, this base. It's in the products like Nair. You know, if you don't want hair on your legs or your upper lip and you don't want to shave, you can go to a pharmacy and you can buy a product called Nair. I'm sure there's other products out there too. What do? If you've ever done it, you smear it on your legs or wherever you don't want hair. Some people put it here because sometimes women have a few little dark hairs here and they don't like that. And they don't want to shave and they don't want to pluck them out. So they use Nair. Okay, if it says leave it on for 4 minutes and then wash, do it. Because guess what dissolves after the hair is gone? Skin. And so they mean business when they say, you know, wash it off. So those are good uses of bases. All right, for salts. It's our garbage term. No H. I'm just going to write it this way, although it's not very academic. No H in front of formula, or and, I should say, not or, and no OH in back. Okay, so when you see a compound, you ask yourself, is it an acid? Does it have an H out front? Is it a base? Does it have an OH out back? If it doesn't have either one, by default, we say, oh, must be a salt. Salt is a broad category. It's not just sodium chloride. Now, Brittany, what did you say?
I was going to say, so basically everything else is salt.
For us, yeah.
So if it doesn't have the OH in the back, it's automatically salt, even if it has the metal on the front.
Okay, if it has, well, here. If I said acid, base, or salt, you would say salt.
Salt.
Okay, but if I say this, you will say base. Let's see, if I say this, you will say acid. Okay, now there's more to it than that. We've got our definitions, acid, bases, and salts. Okay, now, there are strong acids and there are weak acids. It's got absolutely nothing to do with can it hurt you. Here's what it means. If I have HCl, and I put that HCl, the pure stuff, which would be in gaseous state at room temperature and pressure, if I put it into water, essentially 100% goes to the right and produces ions. Now, let's analyze what that means. Here's an H, here's a Cl. Pure state. They are bonded together. I'm going to take 100 of them. I'm going to take those 100 molecules and put it down in water. All 100 of them come apart and they produce as many hydrogen ions and chloride ions as they can. If an acid goes 100% to the right, we say, it is a strong acid. On the other hand, if I have an acid that looks very similar, HF, see, all I've done is trade off one halogen for another. If I put it into water, it only goes about 19% to the right. And I don't expect you to know that 19. It's just way less than 100. And we get hydrogen ions, we get a few, and we get some fluoride ions. But now let's think about what that means. HF. Here's an H, here's an F. They're bonded together. We have a molecule. I take 100 of these. I place them into water. 19 of them come apart. The other 81 of them stay together. So chemists call that a weak acid. It doesn't mean HF cannot hurt you. HF can kill you. But they decided, somebody, and I don't even know when or where, decided that we would define strong and weak this way. Several years ago, they had a big accidental leak of hydrofluoric acid down in Texas City, one of those chemical plants. And I had a student that was working there at the time. And that cloud of it went out through the parking lot, and it killed all the bushes, all the trees, and it started dissolving the glass in the cars. Because it has a property, it will dissolve glass. A lot of people accidentally breathed it in, caused a lot of tissue damage, and there was a number of people hospitalized, although no one was killed. I am sure those people in the hospital, while they're in severe pain and choking up hunks of their lungs, that they're not thinking, oh, no big deal, it was just a weak acid. Because the strong and the weak to us have nothing to do with hazard. It has to do with what they do when you put them in water. If you look at these formulas, it would be impossible to tell without this whole equation who's strong and who's weak. Well, luckily for us, there are just a few strong acids. Your textbook has 7, OWL has 6, and here they are. Ones that are found to be strong. Okay, HCl is strong. HBr is strong. HI is strong. And technically, for them to be acting as a strong acid, I've got to write AQ behind it. They're in aqueous solution. Then we have HNO3, nitric acid. We have H2SO4, sulfuric acid. This is the one that used to be used to take warts off people's hands or feet before the days that they were freezing them off. One way is you could actually burn them off, but chemically burn them off, and they would use nitric for that. Sulfuric acid is the acid in car batteries. So When they say battery acid, they mean that one. And then there's two more, HClO3, and these are the hard ones to remember, I think, because they're not as common. In owl. Owl does not include this one. And their argument is it's rare, you probably won't work with it, but our test bank does. Okay, since our book uses it, our test bank uses it. So, what kind of problem would you have to work? You are going to know that list. And you're going to assume that any other acid in the world is weak. So, test question. I have some of this. And from this moment on, or this day on, as soon as you see a compound fire through your brain, acid, base, or salt, okay, you go, it's a what? Acid. The next thing that should fire through your brain, strong or weak. Which is it? It's weak. The only way we know it's weak, it's not on the list. So this would be a weak acid. And that's the acid, one of the acids they put in all cola beverages, Coca-Cola, Pepsi-Cola, and so forth. It's supposed to be a little pick-me-up in low amounts. So know your strong acids. There's a similar list for bases.